Welcome, everyone. Next up, we've got Narges Baratali. She's an engineer with 7+ years of experience, and she'll be talking about React Native to Native. Her favorite ice cream flavor is peanut butter. She's a Women Tech Makers ambassador, and she loves board games. So give it up for Narges.
So as he mentioned, I'm working at Lumin. And at Lumin, we have our own hardware with more than 20 apps on it. A few of these apps are written in React Native, and we decided to migrate them to Android Native. In this talk, I'm gonna share the journey that how I migrated 2 of our apps from React Native to Android Native, and what choices I made the second time to make my life easier. Also, this QR code takes you to my LinkedIn profile. When I was almost done with the first app migration, I kept thinking that I wish I had a time machine. If I could go back, I would have swapped out half of my components, and maybe I would have changed the way of working. But since the time travel is not an option yet, I decided to create a list of all the lessons learned, so I don't need to find myself needing a time machine anymore. I'm going to share that list with you today. Let me first explain what are React Native and Android Native. So React Native is like a Swiss Army knife. It's a multi-tool that you can use for both Android and iOS. So it's basically a cross-platform framework that you can use one code for both Android and iOS. But it's not always the best app or best framework when it comes to performance. Android Native, on the other side, is like a specialized tool that you can just use for Android. And you have more control on it because it's the native language of Android. And there is always this question that which one we should use. Should we go with Android Native or React Native or maybe Flutter? I'm sure you can guess my preference, but for making that decision, you really need to see what your projects need and what's your goals. So why we even decided to migrate to native? So we had this React Native code and app in our screen, and it was working fine until it didn't. It was so difficult to maintain that code base, and it was hard to solve all the technical depths. One of the benefits of React Native is that you can have iOS code with the same code, iOS app with the same code. But in our case, we didn't even need the iOS app. We just have this one Android device. Something to consider for any type of migration is that you should review your team skill. You should know how many people, like how many developer native or React Native you have in your team. In our team, we had more native developers. And lastly, I think you always have better integration if you go native, because we wanted to use the camera and notification manager. And for the native services, I feel like we had a better integration. Let me share my first story, the first app that I wanted to migrate from React Native to native. So I got this ticket or task, and I wanted to build my React Native code without having any knowledge about React Native. So I started learning how to build it, and I invested so much time to try to build that app. But we didn't even need to do that. So next time, I decided to spend more time and upskill myself in the native because I could actually see the return of that investment that I spent time for native. The first time, I worked more solo and independently. So after building the React Native, I saw the code and I saw the REST API endpoint, and I was like, oh, easy, I can do the same in Android. And without informing the team, I started creating a data layer. And everything was fine, and I came back to inform the team that, hey, I got the 200, I got the result from REST API. And they were like, oh, that's fine. But actually, we had a new GraphQL endpoint that we wanted to use this app. So Communication is always the key. But when it comes to migration, it's more important because you need to make sure you are not making more technical debts in future. Another experience that I had for the first app, I just dived into the coding without asking why and what's the best way to do it. So for example, I started creating my screen and I ended up with a really complex navigation. And I was in the middle of the way and I was like, oh, actually I could use the Compose navigation that was more convenient here. So the second time I decided to take all the tools that I needed. I took a look at the app the second time and I knew that I'm going to need the image loader, PDF viewer, or any other tool that I needed. I just took them the second time. One good lesson that I learned is that always see the big picture. For the first app, I roughly estimated my time based on the screen that I had for the app. And I spent too much time at first. But for the second app, I decided to see the whole complexity because it's not like you have 5 screens and you can just split your time. You should define the complexity and you should know all the details about each function that you have. Let me explain on a picture. So imagine developing an app is like drawing a horse. That's where I was at first, and I wanted to have the perfect code, and it was almost perfect. I wanted to use all the material design. I wanted to have UI tests, even though that I didn't really need them. That was like a perfect code, and I was almost there, and the deadline was nearly there, and I just wanted this to work. So this happened. Not very consistent, right? So the second app, I decided to take a look of all the app and see all the functions. And that's where I gave up the material design system. And that's where I almost gave up everything and I just wanted the app to work. Another hard way that I learned about this lesson, seeing the big picture, was that the first app, I was creating the component in my compose as I needed them. I was like seeing this screen, create my compose and customize it with the UI in that screen. And I was in the middle of the way and I was like, oh, I have some similar UI. I should have made some reusable component. And maybe I could use a state hosting and make some isolated component without passing all the data to make sure it's more reusable. There's something that I underestimated at first for migration, and that's picking the right journey. For the first app, I decided to go with the architecture base. I was like, okay, I'm gonna do the migration for data first, and I'll deal with the UI later. And I've ended up with a huge PR. I thought it's a small app and it's gonna be easy. But it was so hard to break down because I had the whole data layer in there. So the second time, I decided to go with the feature base. And I decided to break down my app into a smallest feature that I actually start with. And because of that, I could have better estimation for each piece of work. And when you have some small feature that you can show, in each step, you can say, hey team, I finished this feature and this is how I've been migrated so far. And you can get the feedback. But that didn't happen in the data and architecture layer. Another good point about feature-based journey was that when you break down your work into the smallest work that you can, you're more clear about how to do it, and you can make it easier. So when you get it done, you get the dopamine hit, you go to the next feature, and I found it really easy, really good and convenient. So this time I was more productive with this approach. I already told you why we decided to go from React Native to native, but now we decided to do this migration. I thought maybe we could add more goals to it. For example, in our case, I decided to improve the performance because sometimes with a few lines of change, you can improve the performance or other goal that you can set in your migration. Something else that you can do in your migration and some other goal that you can set is that you can always enhance the UI and your UX. You might have some ticket in the backlog staying forever, and there are never the high priority to enhance that screen and that UI. But when you're doing the migration, this is the best time to do it because you're touching that part anyway. So learning all the lesson in a hard way, I started the second migration this time. I knew what I'm going to choose for my journey, and I knew I'm going to do it feature by feature. I choose the clean architecture, and in the next slide, I will explain why. And this time, I decided to take all the tools that I needed. For example, I knew that I'm going to use Hilt for my dependency injection, or I knew that I'm going to use more caching this time for better performance. I was more clear about my UI and, for example, navigation in Compose that I wanted to use. And for the test, I knew that I didn't really need lots of UI tests this time, and I knew what unit tests I needed this time. But in each steps, I paused before just doing it. I paused and asked myself why I'm choosing this and what's the best way and which one is more convenient when you're doing a migration. So why I choose the clean architecture? For those of you who are unfamiliar with this concept, it's basically a structured, like layered structure that you have separate layer for your presentation, which is your UI and your view models. You have a separate layer for your data, which can be your data source from API or local database, and you have your optional domain layer. Why it was useful in a migration? First, you can keep things separate. So when you have separate concern, it's easier to deal with them. You don't have to touch everything at first. Another benefit of using this architecture was you can reuse some good part. If you have a good function or if you have some good mapper in your data layer or any good component that you can reuse, you can reuse it this time with a better architecture. Now that I choose the clean architecture, I ask myself how I can improve the performance because it was my goal this time. Well, with a safe hosting and clean architecture, you can actually reduce unnecessary recomposition in your UI, which has effect on your performance. And after that, I decided to improve my repositories with more caching. So instead of getting all the data from API each time, I decided to use more caching and improve my repositories. Why I choose GraphQL? Well, I had to because we had the GraphQL endpoint. But now that I was using it, I asked myself how I can improve the performance with a few small changes. So you can see when you're building your upload client, you can just use the cache, and when you're executing your query or mutation, you can change your fetch policy. I use the cache first, but you can use network only or network fetch based on what you need. But it's not a huge change, but it has effect on your performance. I reached to the point that I wanted to migrate the UI. And one of the big differences between writing an app from scratch and migration is that when you're writing from scratch, it's more likely that you have like a nice Postman document or you have a Figma for your UI. But in my case, I didn't really have a UI or Figma link. I just had this screenshot. So I had to do a reverse engineering from the screenshot. And I created a prototype with those screenshots in my Figma and broke them down into the component. And I created my own design system based on those prototypes. After doing that, I decided to use design token for a better consistency. And this time I decided to go with atomic design principle. I will explain what's that. So atomic design is basically break down your UI and your screen in the smallest component, and your button and your text is like your atoms. And when you combine them, you have your molecules. And you like when you have an image and a description to it, that's a molecule. And when you have a list of these molecules, that can be your organism. And the template is like some reusable that I mentioned, some lists that you can reuse in different screens. And the pages are the final screen with real data. Why even I'm saying this? Because it was so convenient for me to do the migration when I've done the reverse engineering and when I broke down my UI and a screenshot into the small component. With the atomic design, I could just create my own design system and I knew what's my atom. And when I wanted to create some reusable component, I was more clear how to break it down. So there's this example of my app. I knew my atoms are some image or some title. And instead of just using the image component and instead of customizing it everywhere, I created some reusable modifiers that I knew that I'm gonna use in lots of places. And for molecules, I decided to make it isolated from any data so I can use them in different places. And then for having a list, before starting this, I created all the lists and menu that I had in my screen. At the end, when I wanted to create this screen, I already had my data, I already had my component, and it was like collecting everything like a puzzle. And they worked really well together, actually. And at this point, I was done with my migration. After doing the second migration, I decided to do a compare between the first and second migration. Let me add that these two apps, they were very similar and had similar complexity and similar screens. So the second app took me 3 times less than the first app, which was really good. And the usability was much better in the second app because I created some reusable component. And beside the component, I created some good mapper and formatter that I could actually go back and use them in my first app. Because I had to go back and change lots of things in the first app, the modification and redoing thing was almost twice for the first app that I've done. And the consistency is so different when you use a material design and when you use a design system token. You don't have to override the color or the style or topography everywhere. You already set it in your design system and it's automatically done. I've done a small performance comparing between React Native and Android app. The APK size for the React Native was 60 megabytes. Could you guess the Android one, the native one? Smaller, 4.7. Not so bad, right? There's small visual performance. I had to compress the GIF so you don't have to see it for 3 minutes. But even with this compressed GIF, you can see the loading for the first app. It takes a long time each time. And because it doesn't use any caching, you have that loading every time. And it loads all the data at once, so you have to wait a lot. And our customer were happier with the second app, with the performance. In conclusion, there are some tips that might make your life easier. The first thing is you should always have a pre-migration checklist and you should know why you are doing this, what you want to achieve, and what's the best way to do this. After that, you know why you are doing this, and maybe you can add more goals to it now. It's so important to know your migration strategy. If you have some really sensitive part in your app, maybe you should go with risk-based strategy. In my case, feature-by-feature migration was so convenient. You should choose your migration-friendly architecture that is based on your app. I choose the clean architecture, but in your case, it might be MVI. And before just diving into the coding, and like me get too excited for the migration, you should have a prototype and you should test everything and you should trace it in your head and you should know how it might work. That's it. Thanks for listening to my talk. I hope it was helpful. Is there any question?
I remember you said you didn't have a prototype and you had to do reverse engineer. If I didn't hear it incorrectly, you said you didn't need UI testing.
Not as much as the first app. So it really depends on your logics on the app. In our case, we didn't have like a complex UI testing, like compose test. I'm not talking about the manual test. It's more like a automation and UI test. We didn't really need lots of them, and we had. It's not like you don't need them, but you need to prioritize based on your timeline.
See. So when you first develop the app, you're definitely gonna need UI testing, but when it comes to migration, you may not need them that much.
It really depends on your app, and you always need them, of course. But if you have a better design system at first and you have a better foundation, like I spent too much time at first to create a good team to make sure all the tokens are right and all my topographies are working correct. If you spend that time at the first, you have less work at the end. But the UI test is something that you always need, but you need to also prioritize. Is this the first thing that you want to achieve or not?
And that's also the power of working with atomic components. You only need to make the test on the atomic level. And then after that, you only need like unit test for when you do the organism or getting higher and higher. So less test in the end.
Yeah, exactly. Thanks.
Just one question. So you say you did it for like native, say React for native. What about for iOS? What have you done?
So in our case, I didn't bring our hardware, but at Lumin, we created our own hardware. It's Android device, and we don't have the iOS for it.
I'd like to understand a bit more about the fairness of comparison between React Native and Android. It sounds like you had some insights about that conversion, but I mean, the journey that you got is an existing React Native app with that assumes some tech debt that was accumulated over time versus a new Android app, right? So it's not exactly one-to-one. Do you have any insights of if somebody wanted to do, for example, the opposite, going from a tech debt Android native back to React Native? It's like just trying to find a common ground of a fair comparison.
Yeah, I'm sure there are lots of things that you can do in your React Native to improve the performance. And you might have a really old code base in native Android that it might be better to go with the React Native. I don't have much knowledge about React Native, but I'm sure you can do that. It really depends what you want to achieve in your project, and choosing which one is better. It also depends on your team and your project's need. Is there another question?
You mentioned at some point you created some modifiers. Can you tell us, like, what did you gain with that?
So for example, in my UI, I had some menu and some item that I had to change the color when it's focused, or change the title, or change the text, or something like that. And instead of using it every time for different component, I created these reusable modifiers to use it everywhere. Or for example, I had a shape and I needed rounded. Some small detail that you don't have to repeat yourself. You can just use it once, write it once, and use it everywhere.